For centuries, the moon has captured the human imagination. Hanging silently in the night sky, it has served as a symbol of mystery, inspiration, and wonder. Poets have written about it. Scientists have studied it, and explorers have walked upon its surface. It seems so calm, so serene, gently lighting up our nights, influencing tides, and reminding us of our place in the cosmos. But beneath that calm surface lies a hidden truth. The moon, our closest celestial neighbor, is far from untouched. It bears the marks of a long and violent past, a history written in the language of craters, cracks, and cosmic collisions. The moon's surface is a geological archive, and every crater tells a story. These scars weren't made in silence. They were formed by billions of years of impacts from asteroids, meteoroids, and comets. And like Earth, the moon has no atmosphere to burn up small space rocks before they reach the surface. That means every object, big or small, that has crossed paths with the moon has left its mark. And while many of these impacts were caused by small objects, leaving behind minor dents in the lunar surface, others were much more destructive. Thanks to recent data from NASA's Artemis mission, we've been able to look deeper into the moon's past than ever before. Artemis is not just about sending humans back to the moon, it's also about uncovering its secrets. With high-resolution imaging, subsurface scanning, and seismic instruments, Artemis has revealed ancient impact zones and hidden layers beneath the moon's surface. What scientists found is astonishing, evidence of enormous impacts far larger and more powerful than we once thought. These ancient collisions not only reshaped the moon's landscape, they may have influenced its internal structure and even its gravitational field. So what would happen if a similar event occurred today? Let's imagine this scenario: a massive asteroid, several kilometers wide, is on a collision course with the moon, traveling at tens of thousands of kilometers per hour. It approaches with unimaginable energy. The moment it strikes the lunar surface, a catastrophic explosion takes place. The energy released would be equivalent to millions of nuclear bombs detonating all at once. A blinding flash, a shockwave that fractures the moon's crust, and a new, gaping crater that dwarfs most existing ones. The impact would eject an enormous amount of debris, dust, rock, and molten material would be thrown high above the surface. Some of this debris could escape the moon's gravity and drift toward Earth. Others might remain in orbit around the moon, forming a temporary ring system, or crashing back down in secondary impacts. The force could be so intense that it might momentarily distort the moon's shape. Depending on the location and angle of the impact, it could even slightly alter the moon's orbit. And why does that matter? Because the moon isn't just a passive observer in our sky, it plays an active role in life on Earth. The moon's gravitational pull influences the ocean tides, stabilizes Earth's axial tilt, and even affects the length of our days. A shift in the moon's orbit could lead to changes in tidal patterns around the world. Coastal ecosystems, which depend on predictable tidal rhythms, could be disrupted. In the long term, even subtle changes in Earth's wobble or climate cycles could result. Now imagine what we'd see from Earth. In the nights following the impact, a glowing cloud of debris might be visible to the naked eye, a shimmering display unlike anything in recorded history. Telescopes would capture stunning images of the newly formed crater, while the scientific community would scramble to analyze data. But the spectacle could come with real-world dangers. Orbiting satellites could be at risk from high-velocity lunar debris. Space stations and spacecraft might need to adjust orbits or go into protective modes. There's also the possibility that some of the ejected material could enter Earth's atmosphere. While most would burn up and create a beautiful meteor shower, larger fragments could survive re-entry and pose a threat to structures or even people on the ground. Though that's unlikely on a global scale. More subtly, A fine dust veil entering the upper atmosphere might slightly affect Earth's climate, similar to how large volcanic eruptions do by blocking sunlight. Meanwhile, the Moon's surface would be permanently altered. The new crater could become one of the most prominent features on its near side, the side always facing Earth. This would not only change how the Moon looks, but could also affect future missions. Navigation systems for lunar landers might require recalibration, and astronauts would need to take into account new hazards like loose debris fields and altered terrain. So, is this scenario science fiction or a real possibility? Fortunately, impacts of this magnitude are extremely rare. Events like the one that formed the Moon's largest known basin, the South Pole-Aitken Basin, occur on timescales of hundreds of millions to billions of years. However, the chance of smaller, yet still significant, impacts is much higher. That's why missions like Artemis are so crucial. By studying the Moon's impact history, we're not just learning about lunar geology, we're also getting a glimpse into Earth's own past and preparing for its possible future. What we learn from the Moon can directly help us defend Earth. It acts like a natural laboratory for understanding impact physics, crater formation, and the behavior of celestial bodies under collision. That's why planetary defense is becoming a growing focus in space science. Agencies like NASA and ESA are developing asteroid detection programs, early warning systems, and deflection missions. One such mission, NASA's DART double asteroid redirection test, recently demonstrated that we can intentionally nudge an asteroid's path, a major step toward protecting Earth from future threats. The Moon, in many ways, is our guardian. It absorbs impacts that might otherwise come our way. But it also serves as a reminder, an ancient warning written in stone. If we want to protect our planet, we need to learn from its scars. The Moon shows us what can happen when space throws a curveball and how high the stakes can be if we're not prepared. So what should we take away from this? First, that the Moon is more than just a beautiful object in the sky. It's a living history book of the solar system. Second, that we must continue exploring and studying space not just out of curiosity, but for survival. Missions like Artemis are not only expanding our knowledge, but also helping us plan for the future. Space is full of beauty but also full of risk. And the more we understand it, the better we can protect both the Moon and our home planet. If this cosmic journey into the possibilities of an asteroid impact on the Moon fascinated you, don't forget to like this video and subscribe for more space stories, science mysteries, and cosmic truths. What do you think would happen if a massive asteroid struck the Moon? Could it change life on Earth? Let us know in the comments below. We'd love to hear your thoughts. Thanks for watching. Until next time, stay curious, stay safe, and keep looking up.